All right, so 3.6 continues for 3.5, and it does applied problems. So this is applied problems, which sort of means word problems to me. So they first wanted us to start out reviewing what some of the words meant. So I'm going to look at some of the words that mean to add, subtract, multiply, and divide. All right, so word problems, words that mean add would be words like sum, plus, what else? More than, increased by. So if you see some words like that, you know they're wanting you to think about adding. Now the most popular one we'll see is sum, okay? Subtraction. So subtraction, look for words like difference, minus, what else? Less than, and then decreased by. And the big one they like to use on subtraction is that difference. Okay, so let's see. Multiplication, the big one is product times a two-letter word that means to multiply. If you see it, of, like a third of 4, you would multiply that, okay? Multiplied by, stuff like that, okay? The big one is product. On division, we look at quotient. That's the big one for division. The ratio. A ratio looks like a fraction, and that represents division. Oh, let me think some more of them. Divided by. Okay. So just be aware of these words when you're looking at these sentences when they want you to work them out, okay? All right, so before we get into the systems of equations, they want us to translate a statement. So we're going to translate the statement. And it says the sum of 3 numbers is 50. All right, so they're using the word sum, which we know means add. So to represent my 3 numbers, I'll just use X, Y, and Z. And then is means equals, so the sum of these 3 numbers equals 50. Okay, so just remember, is means equals when you're looking at these sentences. All right, let's see. Here they got in triangle ABC, the measure of angle B. Let me move this off my screen. It's bugging me. Put it over here. All right, so the measure of angle B is 38 degrees more than 3 times the measure of angle A. Then it tells me the measure of angle C is 67 degrees more than measure angle A. Then it says find the measure of each angle. All right, so we're going to set up a system of equations like we did yesterday, and then we're going to solve this to find those angles. So I'll use A, B, and C to represent my angles. So first of all, it told me the measure of angle B. So angle B will be my equals 38 more than 3 times the measure of angle A. So that would be 3 times angle A plus 38. So I'm just trying to write out my equation. So I got the first equation that told me B equaled 38 more than 3 times A. Now it's telling me the measure of angle C. So angle C is going to equal 67 degrees more than the measure of angle A. So that could be A plus 67. So I've got 2 equations. I need a third equation, but they didn't give me the third equation. They assume that y'all know the third equation. Since I'm dealing with a triangle, I know that all 3 of these angles equal 180 degrees. So my third equation would be A plus B plus C all have to equal 180 degrees. So this one you have to use a little bit of knowledge on the triangle, okay? So, y'all, the first thing I would do is get everything on one side equal to the numbers and put them in order. So on this one, I want the 3A to the left side and then the 38 left on the right side. So I'm just going to rearrange this. If I move the 3A to the other side, it's going to become a negative 3A plus my B. There's no C. This all has to equal 38. On the second one, if I move this A to the other side, it's going to make it negative. So this one would give me a negative A. There's no B. Plus my C would equal 67. And then the third equation was what? A plus B plus C all had to equal 180. So that's tricky just getting it set up, but once you got it set up, now we can solve this. All right, so I'm going to call this row 1, row 2, and row 3. Now remember, you could do this on the calculator, put zeros where you don't have the letters at if you're doing the matrix, okay? So I'm going to try to solve this by hand. And notice, I've only got 2 B's and I've only got 2 C's. So I'm going to try to get rid of one of these letters first. So what I'm going to do is try to get rid of the C's. So I'm going to get rid of the C's. Now, since they're both positive, I'm going to multiply row 2 by a negative 1 so that I can make that C negative, okay? So I'm going to multiply row 2 by negative 1 and then add to row 3. All right, so let's see. Take row 2, multiply by -1. So we got -1 times negative A plus C equals 67. So all that -1 is going to do is change all the signs. So negative times negative makes that a positive A. Negative times positive makes that a negative C. And then negative times 67 makes that a negative 67. Now bring row 3 under here. A plus B plus C equaled 180. All right, y'all, so here we go. A plus A gives you 2A plus the B. The C's cancel. And then 180, let's figure it out. 180 minus 67, what's that, 113. So this will be my row 4. But y'all look at this. I used row 2 and 3 to get row 4. Row 1 already has the C gone. So the next 2 rows I add will be row 1 and row 4. So I'm going to add row 1 and row 4 now. So y'all watch this. We got negative 3A plus a B equals 38. I got 2A plus B equals 113. So since these B's are both positive, I'm going to multiply the first one by a -1. Let me let y'all write that a second, then I'm going to flip my paper. All right, so the next move I'm going to do is distribute that -1 on the top. So if I distribute the -1 on top, that'll become a positive 3A minus the B equals a negative 38. My other row was a 2A plus a B equaled 113. And y'all look at this. 3A plus 2A gave me 5A. The B's canceled out in the middle. And then let's see, a negative 38 plus 113 gave me 75. So now we're happy. We're down to one variable. So let's divide this by 5 and see what the A equals. So that cancels, and I finally get A equals 75 divided by 5 is 15. So I know that A was 15, so now I'm going to back substitute. And I'm going to go into one of the 2 equations that I just used. And I'll probably just take the, which one's easier? I'm going to do the 2A plus B has to equal 113, which was that second equation I had up here. Because I know what the A is now. A is 15, so that'll be 2 times 15 plus B equals 113. All right, let's multiply 2 times 15 is 30 plus B equals 113. And then one more move, we'll have B. So we'll subtract 30 from both sides. And finally, I got my B equals, let's see, 113 minus 30 will give me 83. So I now know A is 15, B is 83, so I'm going to back substitute one more time into one of the original 3 equations. And I'm just going to use A plus B plus C all have to equal 180. We know A was 15. We know B was 83 plus our C equaled 180. So y'all, let's add the 15 and 83. That's going to give me 98 plus the C equals 180. So all I did was add the like terms. Now, since I got 98 plus C equals 180, I'm going to subtract the 98 from both sides. So that cancels, and I get my C equals, let's see, 180 minus 98 is going to give me 82. So my angles were A was 15, B was 83, and C was 82. So I'm going to add them together real quick. 15 plus 83 plus 82 equals 180. So those are a little tricky to get set up, but once you got it set up, just go through there and try to eliminate them variables, okay? All right, so we'll do another one like that. Well, now we'll say this question I'm about to do, put a star by it, because we love to use this question on the test, and we love to use this question on the final exam. So it says the sum of three numbers, so the sum of three numbers is 54. All right, the difference of the largest and smallest is 47. And then it says the sum of the two smaller numbers is 13. So then it says find the numbers. And if you notice on this one, they actually gave me all three equations because I wasn't dealing with a triangle or some kind of geometry, okay? So the first thing I'm gonna do is write out the first sentence. It says the sum of three numbers is 54. So I'm just gonna say X plus Y plus Z equals 54. And then notice this next sentence says the difference of the largest and the smallest is 47. So what I'm going to do, X column is going to be for my largest number, then my middle number will be the Y, then my smallest number will be the Z. So large, medium, small, okay? Because this one says the difference of the largest, which is X, and the smallest, which is the Z, is 47. So now we got to figure out what difference meant. And remember earlier we said difference meant subtraction. So that Z has to be negative. Now, the Y would be a 0 on this equation because it wasn't in the problem, okay? And then the last one says the sum of the two smaller numbers is 13. Well, my middle number and my smallest number have to equal 13, so that'll be a Y plus a Z equals 13. So once again, I would call this 1, 2, and 3. All right, so I'll probably do this just like I did the one with the triangle just now, because you notice you've got only two x's and you've only got two y's. So I would try to get rid of one of them, and then it'll make your problem a lot simpler, okay? So, hell, I'll get rid of the y's this time, okay? So I'm going to eliminate the y's first. So since both my y's are positive, I'm going to multiply row 3 by -1. And add to row 1. Now the reason I picked this one to be my negatives because there was 3 things up here versus the 2. So here we go, -1 multiplying by row 3, which is a y, plus a z equals 13. So remember, all that negative is going to do is change all the signs. So I get a -y, a -z equals a -13. Then I'm going to bring row 1 down, which is a x plus a y plus a z equaled, oh, what was that, 54. All right, so this one I made both these negative and the 13 negative. Then I brought down my row 1, and I'm getting rid of the y's. But y'all look at this. Add these together, look what happens. The x comes down, the y's cancel, the z's cancel. So if I can add this together, let's see, -13 plus 54 is going to give me x equals 41. So now since I know x is 41, this equation only had x's and z's. So I'm going to back substitute into that one. So I'm going to use x minus z has to equal 47. Well, x was 41 minus z has to equal 47. So y'all to solve that, I'm going to subtract 41 from both sides. And so be careful, that's a -z at the moment. And then 47 minus 41 is 6. But remember, I cannot leave my variable negative, so we're going to divide by -1, and a positive z equals a -6. So now I know x is 41, z is -6, so I'm going to back substitute for the last time, and I'll probably just pick that first one, x plus y plus z equals 54. But y'all could have used this one, y plus z equals 13. So let me try that one. Y plus z equals 13. I don't know y yet, but I know z is a -6. That's got to equal 13. All right, y'all finish this out by adding 6. And y equals, what's that? 13 and 6 is 19. So let's see what we got. For the x, we got a 41. Y was 19, and z was -6. I'm going to add them together. 41 plus 19 minus 6 equals 54, which was what my very first equation said. Ooh, those got a lot of work on them. Now, y'all, right here where I wrote this equation, I'm going to show you this one on the calculator again. So to put that in the calculator, you would go to matrix, which is second x -1. So go to your matrix, arrow over to edit, and hit enter. Now, we got 3 rows by 4 columns. So 3 is good, and the 4 is good. Now, every place has to have a number. If there's a missing variable, we're going to put a 0 there. So for the first row, you have 1, 1, 1, 54. Then you go to the second row. You got 1, no y, so that's a 0, -1, and then 47. Then you go to row 3. You don't have an x, so that's a 0. Then I got 1y, 1z equal 13. So I got all that entered. I quit the screen. And then now what I'm going to go do on there is find RREF. So you hit second, x -1 to get the matrices. Go to math. On math, you're going to arrow down and find RREF, which is B on mine. Hit enter. Then let's go back and get the matrix by hitting second, x -1. And since I always put mine on A, I just hit enter when I do that. So now your screen is going to reduce that matrix to get our 3 answers. And y'all, there we go. The first column was the x's. So this tells me 1x is 41. Second column was the y's. So since there's a 1 here, that means 1y was 19. And then the last column was the z's. And this is telling me that 1z is -6. And there you go. So you sort of got to like that calculator. It does a lot of work for us. All right, so this one's sort of a nutritional type problem. It says by eating 1 egg, 1 cupcake, and 1 slice of pizza, and 1 slice of pizza a child consumes 300 milligrams of cholesterol. If child eats let's see, 3 cupcakes and 4 slices of pizza, they take 92 milligrams. So they get 92 milligrams of cholesterol. And then finally, eating 3 eggs and 1 cupcake, they consume 836 milligrams of cholesterol. So you know the question, how much cholesterol is in each item? So I wonder, egg, cupcake, or pizza, who's going to have the most cholesterol? Well, we're about to find out, I guess. Oh, and this up here, it says, looks like child. That should be child. All righty, so I'm going to put these in order of the first one. I'm going to put my eggs in the first column, my cupcakes, second column, my pizza, and then the cholesterol. So I'm just going to put them in that order. So the first one said 1 egg, which is an X, plus 1 cupcake, which is a Y, plus 1 slice of pizza, which is my Z. All that has to equal 300 milligrams. Now, I don't have to put the ones. I was just doing that to show y'all what I'm doing. Now, second one says he eats 3 cupcakes, which is 3y, plus 4 pizza, which will be 4z. That gave us 92 milligrams. And then finally, the last one said 3 eggs, which will be my x's, and 1 cupcake, which will be my y. They consume 836 milligrams. All right, so once again, if you're doing this on the calculator, put a 0 for that x and a 0 for that z. All right, so we got row 1, 2, and 3. All right, so let's see. I got x's and y's here, y's and z's here. So I'd probably try to get rid of the z's or the y's. So what I'm going to do is get rid of all the x's. Yeah, I could do the z's. I'm going to do the x's, I guess. So what I'm going to do is multiply row 1. You know what would be easier, actually? Nah, I'm going to do that, x's. So I'm going to multiply row 1 by -3, because that's a positive 3x. I need a negative 3x there. And then add to row 3. That should say to row 3. All right, so number 1, we got -3 times 1x plus 1y plus 1z equal 300. So distribute that, you get a -3x, -3y, -3z, and then -3 times 300 is a -900. Now, bring in row 3, which is a positive 3x plus a positive 1y. That equaled 836. All right, so the x is canceled. -3 and 1 give you -2y minus the 3z. And then let's see, we got a -900 plus 836. That's going to give me a -64. So I'm going to call that row 4. So it's got y's and z's, but look, row 2 also has y's and z's. So I'm going to put them two together. I'm going to do -2y minus 3z equals -64. And then I'm going to bring down a 3y plus a 4z equals 92. All right, y'all, so this is probably the first time that we've hit this where you've got to actually change 2 rows to get rid of something. Because notice, I can't multiply the -2 by anything to make a 3 or a -3. I can't do anything here. So what I've got to do is change both rows. So 2 and 3 look smaller than 3 and 4. Now I'm happy, that's negative and that's positive. So what I'm going to do on this, I'm going to take the first row and multiply by a 3. I'm going to take the second row and multiply by a 2. That way, this will give me a -6. This one will give me a +6. So let's distribute and do that. So 3 times -2 is -6y. 3 times -3 is a -9z. 3 times -64 is -192. Now distribute a 2 on the next one. So 2 times 3 is 6y. 2 times 4 is a +8z. And then 2 times 92 is what, 184. But notice now, when I add these, I'm going to get rid of the y's. Negative 9 and 8 give me a negative 1z. Negative 192 plus 184 should give me what, a negative 8. But y'all remember, I've got to make that variable positive so that z equals a positive 8. So now I would go back into back substituting. And I'm going to pick the second equation because it's got y's and z's. I know the z, so I can find my y really quick. So let me pull that over. So I'm going to go to the 3y plus 4z. 3y plus 4z has to equal 92. I know the z is 8, so that'll be 3y plus 4 times 8 equals 92. So y'all, what I'm going to do is bring down my 3y. 4 times 8 is 32. Next, we'll get to 3y by itself by subtracting 32. So I bring down that 3y. That's going to equal 92 minus 32 would be 60. And then finally, to get to y, divide by 3 on both sides. And y, 60 divided by 3 would be 20. So I know z is 8, y is 20. So to get to x, I'm going to use, so we're going to back substitute one more time. And I'm going to use 3x plus 1y equals 836. Because I know the y was 20, so I got 3x plus 20 equals 836. We're going to subtract 20 from both sides. All right, so what's that going to give me? 3x over here. 20s cancel. 836 minus 20 would be 816. And y'all finally divide by 3. So let's see, that is 816 divided by 3 is going to give me 272. So my answer would have been 272. What was y? 20. And then z was 8. Now, it'll probably have blanks. So it'll probably do like this. Eggs equal, what was next? Cupcakes equal. And then the pizza equal. So remember, my first column was eggs, which were my x's. So the eggs were 272. Cupcakes were my y's, that got 20. And then pizza was my z, which got the 8. So it looks like the eggs got the most cholesterol on that problem. All right, so that was 3-6. So I'm going to let y'all take about a 10-minute break, and then we'll knock out 3-7, okay? So I'm going to pause this for a second. All right, so I'm going to go back to my screen. All right, y'all, so 3.7 deals with systems of inequalities. Which is like your less than, greater than, less than or equal, greater than or equal. So when you're graphing these, you got to figure out if you're going to shade them above the line or below the line, and whether you're going to use a dotted line or a solid line. So graphing inequalities, if you have less than or equals or greater than or equals, you use a solid line. okay? Second, if it's less than or greater than, and it don't have the equals in it, then you use a dotted line. So 1 and 2 tell me what kind of line to use. Solid if it's got equals, dashed if it don't. 3 and 4 tell me whether I shade above or below. So if it's greater than or equals, you're going to shade above. And then if it's less than or equal, we shade below. So they got like 3 or 4 problems where we just graph an inequality. And then the last one I do will be a system where I have 2 inequalities and I graph them. So first, we're just going to graph y is greater than x minus 2. So let me make me a little table. So it's already in the form I want it, y equals mx plus b type stuff. So I'm just going to pick 2 numbers, 0 and 1. Those are easy to do. So if I put a 0 in for the x, 0 minus 2 gives me a -2 for the y. So all I did was put a 0 in. Then if I put a 1 in for the x, 1 minus 2 is -1. So now I've got 2 points. So I'm going to pull up my graph paper to sort of put right by this. All right, so let me draw my graph. All right, so that'll be the x and the y. So my first point was 0, -2. So starting at 0, I would go down 2 to -2. My next point was 1, -1. So I would go right 1 and down 1. So now I can tell where the line's going to go. So let me look at my equation. I had y was greater than x minus 2. Since that was greater and it didn't have a line under it, I'm going to use a dotted line for my line. And then greater than, it told me right here, greater than shades above the line. So you would come in and shade that part above the line. So what this means is that any point in this shaded area makes this true. Any point that's not in the shaded area makes that equation false. So like here's 0, 0 in the middle. You put a 0 in for the x, you get 0 greater than 0 minus 2, which would be 0 greater than -2, which is true. So we know we shaded the right area. And y'all, this is nice on the calculator because it'll do these problems. So I would go to y equals, and I'm going to put in x minus 2. So x minus 2. Now to make it shade, what you do on the calculator is you arrow all the way left of that y1 over here, and it blinks on that little, just blinks over there. What you do to shade above, you want a triangle that looks like it's above. So let me hit enter and I'll show you. So hit enter, enter. Right there, you see how that triangle looks like it's above? And then if I was going to shade below, I'll hit enter and show you the triangle's on the bottom. So hit enter until we get that triangle above again. So there it is, that's the triangle above. And all we got to do now, we're telling the calculator we want to shade above the line so that when we hit enter, it makes a graph that looks just like ours. Now, the only thing the calculator won't do is the dotted lines. So you just have to pay attention to the math lab. when you graph these on MATLAB, you gotta choose. It'll have a little box there with a solid line and a dashed. If your line is dashed, you gotta choose the dashed line tool when you're graphing it, okay? All right, y'all, let me try the next one here. So this one has 3x minus 2y is less than or equal to a -4. Sadly, you're going to have to solve this for the y if you want to do it on the calculator. Okay? And it'd probably be easier to do this solving it for the y. So what we want to do is get the y on one side, everything else on the other. So first of all, I'm going to move the 3x by subtracting. So that'll bring down that -2y, less than or equal. These are not like terms, so I usually put the variable first, the -3x, and then the -4 at the end. That way it looks like y equals mx plus b. Now next, since that's a -2y, we need that to be a positive y. We're going to divide everybody by that -2. Since I'm dividing by negative, I got to reverse the inequality so that it is now greater than or equal. So remember, anytime you divide by negative, you got to flip that around. So that cancels. I get a y greater than or equal to. Those two negatives make that a positive 3/2 x. And then these two negatives make that a positive 4 divided by 2 is 2. So by hand, I'll tell you what numbers I would pick. I would always pick a 0, because 0 times 3/2 is 0, and 0 plus 2 is a 2. Second number I would pick, since there's a fraction there, since there's a 2 on the bottom of the fraction, my second number would be a 2. And I'll show you why. When I plug that in, those 2's cancel, making a 1. So you get 3 times 1 is 3 plus 2, which means y is greater than or equal to a 5. So when x is 2, y is 5. I always pick numbers that match the fraction so I don't have to try to graph a fraction on this thing, okay? All right, let me see. I might be able to put this graph here. So there's my x and my y. And I'll just make about 5 little clicks on here. So 0, 2, starting at 0, you go straight up 2. 2, 5, you go right 2 and up 5. So I can tell my line's sort of going to go uphill. Now, this time, since I got equals in this is going to be a solid line. And then it is greater than, so it would shade above. Okay, so I'll do that on calculator. So remember, the first thing you got to have is this thing solved. So then I would do 3 divided by 2 times x plus 2. Now remember, this one shades above, so I'm going to arrow all the way left and hit enter until I got my triangle above, right there, and then graph. And y'all look at that, it looks just like our picture, so we're good and we're happy. All right, this one you cannot do on the calculator. It has x greater than 5. Now, I'm not going to lie, some of them fancy Inspires might be able to do this, but most of the basic 84s won't do it. So if you was going to set up a table for a question like this, since there's not a y variable in here, it don't matter what the y values are, but every single one of these x values has to be 5. Okay? So x's have to be 5. And then the y's can be anything. So you could pick what, a 0 and a 1 if you wanted to. So let me get my papers turned. So x and y. So let's go 1, 2, 3, 4, 5. So when you get x is greater than 5 or x equals 5, that is going to be over here at 5 on the x-axis. That's going to be a vertical line. And since there's no equals, it's going to be dotted. So 5, 0, 5, 1, 5, 2, 5, 3, and so on. Every x value had to be a 5 when you got a question like this. Then it says greater than. Well, when you're dealing with x's, greater than's to the right, less than's to the left. So on this one, we would shade everything to the right of 5. So if it's shaded, then the x value has to be greater than 5. So this is shaded. 6 is greater than 5. 7 is greater than 5. All these values are greater than 5. Now this one you can do on the calculator because it's a y. Y is less than or equal to a -3. So if I was going to do a table on this one, since it has only a y, that means every y value has to be -3. And this time, x can be anything. So I'd probably pick what, a 0 and a 1 on those. So x's are vertical lines. The y's are horizontal lines. I'll say, so my y's were negative, so I'm just going to go down in the negative direction. So 0, -3 would be here. 1, -3 would be here. So that this is going to be a horizontal line going across -3. And it's going to be solid since there's the equals there. So I would just come in and make that a solid line. It's less than, so less than would shade below. So that every y value that I shaded is going to be less than or equal to that -3. Now, like I said, you can do that one on the calculator, so I'm going to clear that. And all I have is a -3. There's not a variable at all for the x's. Now, arrow all the way left. This is less than, so I'm going to hit enter until I get the triangle that's on the bottom. That one's above, that one's below. And then hit graph. And y'all, there it goes. Shot it straight across horizontal line and shaded everybody below that -3. All right, so let me write a few notes before I do this last one. So when graphing a system of inequalities, the solution is the double shaded region. Okay, so one might be greater above, one might be greater below, but the answer to the overall system will be where they overlap their shadings. So here we go. We're going to graph the system of inequalities. So I got y is greater than or equal to x plus 4. Then I got y is less than or equal to 1 minus x. So you would have to come down here by hand and set up 2 tables, one for each line. And I'm going to pick zeros and ones on both of these because there's no fractions to worry about. So the top equation I'll do on the left one, and the bottom equation I'll work over here. So for the top equation, if I put a 0 in for the x, 0 plus 4 will give me 4 for the y. If I put a 1 in for this x, I get 1 plus 4, which is 5. So I got 2 points to graph the first line. Now let me look at the second one. If I put a 0 in for the x, 1 minus 0 is 1. If I put a 1 in for the x, 1 minus 1 is 0. So I got 2 lines I can now graph. And let's see, looks like 5 is my biggest number, so I'll just go out about 5. All right, so the first line had 0, 4, so starting at 0, go up to 4. And then I had a 1, 5, so go right 1 and up 5. Now that first line had an equals under it, so that's going to be a solid line coming down through here like that. Now, it said shade above, so on this line, it's shaded above the line. Now I'm going to graph the second line and see where it shades. Well, the second one had 0, 1, so go up 0, 1. And then it had 1, 0, so go right 1 and stop. That line also had an equal, so it's going to be solid. This one was less than, so less than is going to shade below the line. So I'm going to go the other way for it. So that the solution would be this section right here where it is double shaded. So you'll have like answers, and you'll want to answer where it's over here shaded, okay? So it'll only have that one section shaded on your answers. Okay, so on the calculator, watch this. That ain't bad on the calculator. You just got to put each line in it. So this one was the x plus 4, x plus 4, arrow left, and it's shaded above, so hit the upper triangle. Then go down here, put in the second equation, which was 1 minus x, and then I'm going to go left, and it's shaded below, so I'm going to hit enter until I got the bottom triangle. Now y'all watch this. It's nice on the calculator because it's pretty clear. There went my first line. There goes my second line. So notice the shaded area was pretty much like what we had here. So that is the only answer you want on the final answer, okay? All righty, so that section wasn't very big, so that is all the information that's going to be on test 1. So I'm going to stop my share, and then I'm going to quit this video.